Hello, this is Pablo from STT. Welcome to this very brief and quite simple introduction on iSen. I'll try to explain how the workflow is carried out in this software, how to use the sensors, how to display the different data sources, how to export information, and so on. I'll try to give a brief overview so that anyone interested can understand the different modules and possibilities of this application. So I'm going to run iSen 2017, the latest release version as of now. As you can see, there are basically two tabs here. The main tab with the basic features and operations. And there's a second tab for the configuration with a few advanced features and, well, as its own name explains, it's just configuration issues. The interface is arranged in different modules that can be locked to any part on the software, on the interface. You can freely move them around and the software will remember how they were placed last time. So I'm going to open a recording. In this case, I will access the database. As you can see, there are a number of different recordings from different patients or athletes. Some of them are obviously test recordings. I'm going to pick a simple one sensor recording. In this case, I think I'm going to pick this one, a basic gait analysis. This is the most simple gait analysis that you can perform with iSen. It uses just one sensor and it is placed on the sacrum. As you can see, a few elements popped up in the interface. This blue area here is the 3D interface where the visualization happens. Everything is paused now, so there's no motion in here. There is a module that is called dashboard, which shows a summary of the parameters that are considered as most important, most relevant for each protocol. In this case, since we're talking about gait analysis with just one sensor on the pelvis, I'll be getting information on the 3 rotations of the pelvis, plus a few additional gait parameters. And there's another module in here that will show the graphs over time. In this case, since I have just one sensor, I'll be getting a very simple chart with just the 3 rotations. The time cursor is here. I can click on it and drag it to see the motion back and forth. I can, of course, play back the recording. I can toggle on and off the different orientations. There are different modules. Everything is synchronized, so I'll be getting the motion together with the time graphs. As you can see, there are some vertical lines, dotted lines in here. These are different events that in this case were automatically generated. The green dots indicate a limit. Well, this was actually added by the user. This is an initial limit, and this is a final limit for the analysis. We're telling the software to focus the analysis on this period of time, basically. And then there are a few other elements, a few other events in here. There's a blue item, a blue event called left initial contact, and then there's a right one, right toe off. In this case, it is a red event. These are automatically generated by the software based on the curves, just on the curves. The more curves we have, the smarter the software will be in detecting these events. But I can, at any point in time, I can just remove those events if I want to. So I'm going to go to events and then get rid of them. I click OK, then I could get them back. If I click here, gait detection, the software will try to calculate the gait events based on the information available, which is very little in this case, just a very simple recording. So what else? There are a few other modules or windows that I can display in here. So for example, in the case of biomechanics, I'm currently displaying the charts, which is this module over here, but I can also display the data. The data will basically show the same information, but as a number, which can be interesting in order to know the value of a specific segment at a given point in time. As you can see, this refreshed real time. Let me hide this one. This is the dashboard, which I can hide or display as well. Then there's a group of 3 icons or 3 buttons for the sensors. None of them is displaying anything right now, but if I click here, I will be getting the animation, the real-time animation, or in this case, the playback animation of the actual sensor motion. As you can see, you can imagine the person walking this way with the sensor placed in here. I'll be using a feature now to properly align the view. I'll be doing this. Okay, so now this is a rare view of the subject walking. You can imagine him. And this is the sensor as it is seen from outside. Okay, let me go back to the other one. Again, I can also display sensor data. In this case, this is the raw data that is generated by the sensor. There is just one sensor, number 1, and I can take a look at the quaternions, the absolute angles, rotations, as Euler angles, and also different projections, temperature, barometer, humidity, battery. Everything is stored with the recording, so it is very easy to go back and take a look to whatever was recorded. And I could also show the charts, but this is not very relevant. The charts will show the same information as the numerics, but as a chart instead of as a number. Let me hide this one. If I were using external devices such as force plates, EMG, data gloves, and so on, I could display this information in here. So the software provides a separate module to display this information. In this case, it is empty. I forgot something important, and it is the export feature. So I can easily export the information of these charts by just clicking here. I could generate a CSV file, as you can see on the left side, CSV file, or I can just export and save the file without opening it. This will export the file. It will generate a file with the data from all selected plots, and this one only the current group. And then there are a few other things here. The plugin views will show this. This is the video feed, if there was any. In this case, it seems that the recording had no feed, so I'll be showing this later in a minute. Let me hide that one. And then there's a rules module. The rules editor is also known as the biofeedback module. The biofeedback module is very interesting. It allows us to generate certain rules or conditions based on simple or composite rules that will help the user know or spot certain events or certain circumstances. It will be like an alarm in case a certain condition is fulfilled. You can imagine this as a real biofeedback tool, real-time biofeedback tool. So for example, in this case, I would choose any of the available parameters, biomechanical parameters. There are just 3 of them. Imagine that I wanted to know, let me cancel this. Imagine that I want to know if the pelvis tilt goes beyond or above 12 degrees. As we can see, it's happening here in this region. Okay, then I would go here, here. Sorry, rules. Add simple rule. I would select the parameter first, which would be the tilt, pelvis tilt. Okay, and I want to know if it is greater than 12 degrees, as we said. And then if that happens, I want to, in this case, I can choose either for a sound to be played or a visual alarm to be shown. In this case, because I want to avoid the sound playing right now, I will just click this one. I click OK. This is a summary of the rule I just generated. I click OK. And this is the visual representation of the rule. So now, whenever that rule is fulfilled, a visual alarm will be shown. In this case, it's just a text. If I select the audio option, the sound option, I will be hearing a sound. This works in real time, so it will be an interesting tool for training or retraining or physiotherapy, rehabilitation, in order to show a patient whether a certain movement is appropriate or not. There is a future upcoming update actually for these rules that will be, let me quickly say that. we're going to add a couple of new features here. We're going to add a new feature that is the system will be able to add events. So whenever the condition is fulfilled, the system will generate certain events on the chart. That's very useful if you want to post-process a certain recording based on a set of rules. And the software will help you find the moments, the times in which those rules are fulfilled. That's interesting for quick processing. Okay, so let me close this one. So how does, we want to continue, yes. How does a standard recording works? Very simple. I would click on a new analysis, As you can see, there are a few red or orange icons here. Those are related to a new recording. I would click on new analysis, then I get to the protocol wizard, as we call it. The protocol wizard is basically a library in which I can access the different protocols. If I wanted to perform a gate analysis, I would click on gate analysis, and this is the list of available protocols. There are a few of them. Each one deserves an explanation, but there's no time, so we want to do this in a short way. So I would click, for example, on lower train, the standard one. It uses 7 sensors. The position of the sensor is displayed here. These are a few pictures. This is a summary of the parameters that are provided by the system. I would then click on next. If there was sensors, in this case, the system was trying to connect a certain set of sensors, but there are none. If there were sensors here, actually I would like to connect STT-IWS sensors. Those sensors would be displayed here, and I would just assign them manually, or I would click on automatic assignment. And those sensors would be automatically assigned to the different body segments. I can also modify the configuration for certain parameters. So for example, whether I want to use low frequency or high frequency in the data acquisition up to 400 Hertz. I can use 400 Hertz for up to 16 sensors, which is a lot. Yeah, and that will be it. So basically, I have no sensors here, but you can imagine how this goes on. Next thing, let me open another example. In this case, it is a 7 sensor lower train analysis. I wanted to show you the same one that I just picked in the protocol wizard. So I will select one of these examples. I think all of them have some videos, so they will be more meaningful. I'll open a sample lower body analysis or gate analysis. Here we go. So let me check if there was video here. It seems that there was no video. Let me see if one of these has video. Yeah, this one has. Very good. Yeah, the room is not particularly clean, but it will be okay. So first thing, I will center the view. Let me use the left view. That's all right. So in this case, we're looking at someone walking in our room. Supposed to start right now. Very good. There we go. It seems that a video camera, so a webcam was used, which is the simplest solution for video feed, as you can imagine. But we could also use a high-speed camera to get, for example, 100 frames per second, and then also record at 100 frames per second with the inertial system, so that we could get a one-to-one relationship in terms of frame rate. But anyway, a video camera could be okay. A webcam could be okay for a quick analysis. In this case, as you can see, this video shows someone walking in a room. I will use my arrow keys to move forward. Very good, just to show you the different frames. Okay, so let's look at the plots. Again, I have a few, quite a good number of plots here. Basically, there's a pelvis group, there is a hips flexion extension group, and then the other two planes as well, abduction, adduction, and then hip rotation. If we look at the very popular curve for the knee, for example, and then we go here. Okay, we can see both curves at the same time at this particular point in time. The events have not been generated, so I could go here and ask the system to automatically calculate the gate events. This is magic. Well, not magic, but it is based on all curves available. The more curves you have, the better the estimate is. In this case, since we are using a 7-sensor lower body analysis system, or configuration, sorry, that's a very high number of sensors. It's okay. And the resulting curves will be pretty good. You can zoom in and zoom out very easily. In this case, it seems that the person went back and forth a few times. And there was also, well, this event is actually showing the initial position. The initial position is something that you need to do in order to get accurate information. It basically calibrates the the sensor to bone offset, orientation offset. Okay, so let me take a look to other modules here. I can display the sensors like we did before, only that in this case we have a higher number of sensors. As you can see, there's a dot here. This one is showing the battery life, battery charge. All of them were pretty high at this point. And you can see all of them moving simultaneously. The label here shows the position, the anatomical position. So this was the pelvis sensor, the left thigh, and so on. So what else? The report generation. I didn't explain that. So all protocols have a report that can be automatically generated, and these reports are provided in the form of a template, a docx template, so that the user can customize certain parts of the report. It wouldn't be that easy to insert new parameters if those parameters have not been calculated by the biomechanical module inside iSen, but it is very easy to modify, to edit the template, in terms of format, removing or adding texts, removing or adding logos, pictures, comments, removing plots, or whatever. So we can say that it is reasonably customizable, the report. In this case, I'll be using a LibreOffice, which is a free text editor. All right, so here's the report, which is, as I said, a very simple report, including the different joints with rotations, flexions, and so on. Let me zoom in. As you can see there, its graph includes a region in blue or in red. That's because it is using all available strides, in this case, to compose. And then the thick line inside, that's the average. Very good. So if we open a different recording with different number of sensors, I can obviously take a look at different configurations. Let me open a higher, this one is a full body, for example, full body recording. All right, here we go. In this case, we have obviously more graphs for different body segments. Use shoulders, elbows, torso, pelvis, hips, knees. All the curves that you would expect. Actually, lots of them, probably too many for most scenarios, for most cases. This one is a longer recording. around 2 minutes. Let me go to where the initial position was taken, which is right here. I will choose a more convenient point of view. In this case, for example, the right. Oh, let me check if there was a video here. I think so. I think there was. This one has a video. Plugin views. Exactly. This is the one with video. Skip. Okay. Right view. Very good. Let's see what this person is doing. He's still standing in the reference position and then starting to acquire data. Yeah, doing some tests with the knees. Obviously, the angle is the same for both knees. And then moving back and forth. Let me change that. Again, a webcam was used. That's why the frame rate is not very high. And also there are many more frames coming from the 3D generation, I mean the inertial system, than the number of frames generated by the webcam. But anyway, for just simple visual feedback, this is just all right. All right, so this is a quick overview of how iSen works. We explained a little bit how the different features are prompted. There are a few others like this one, screenshots, but you can add pictures or snapshot to the reports very easily with this button here. Yeah, there are a few other ways to export data. You can export directly the raw data coming from the sensors. These are the sensor names for this particular customer. And you can choose which sensors you want to export and what data types you want to export. This will generate a CSV file or an ASCII file with the raw data, which can be interesting for further processing or research. We could also export the events, a list of events. That's very simple. In this case, there was only initial position, which doesn't make a lot of sense. And then you can also generate a video file coming from the 3D view. A video file coming from the 3D view. This will generate just an AVI file that you can easily, show to other people or upload to the internet or whatever. This is the user manual with the different user guides. Well, I guess that's it. So I hope I gave you a general overview. Obviously, there was something missing here, which is the actual recording of information, which can be done through an online presentation, which I will be glad to show if needed. All right. Bye-bye. Thank you.